like to share our work, RiDDLE Reversible and Diversified De-Identification with Latent Encryptor. We propose a novel de-identification method with better quality, higher diversity, and stronger reversibility. The identity of the face is important and is widely used in different situations like travel, payment, etc. Face de-identification aims to hide the identity information of face images for privacy protection. An example of face verification is shown below. Given two images of the same person, the face recognition system will identify both images as having the same identity. However, if one of the images is de-identified, face recognition will fail. Despite the progress have been made, current de-identification methods have the following three drawbacks. The first is the lack of diversity. Many existing works tend to generate faces with homogeneous appearances for different people, which is easy for a hacker to realize that these faces are anonymized. Secondly, most of the previous works only pay attention to the process of de-identification and neglect the importance of identity recovery. Lastly, the image quality of current de-identification methods is still unsatisfactory. To solve the above problems, we propose RiDDLE, short for Reversible and Diversified De-Identification with Latent Encryptor. RiDDLE performs identity encryption and decryption on the latent space of a pre-trained style GAN2 model. High-quality and diversified anonymous faces can be generated with the proposed password scheme. Here is the latent identity encryption and decryption pipeline of RiDDLE. The face image is first projected onto the latent space with a style GAN inversion encoder, and its latent code together with a randomly sampled password is processed with a lightweight encryptor, which yields the encrypted code. During decryption, the password and the encrypted code are processed with the same encryptor, which yields the decrypted code. The style GAN generator takes the latent code as input and generates the corresponding face image. Only the correct password can recover the original face, otherwise, a de-identified face with realism will be returned. It is worth noting that RiDDLE also supports data-free training when the training dataset is not available, since latents can be randomly sampled with the pre-trained style GAN. Loss functions play an important role in RiDDLE. To improve the diversity of the de-identified faces, the similarity for the identity embedding of the following image pairs is minimized. Two de-identified faces with different passwords, two wrongly decrypted faces, and the encrypted-decrypted face pair. To achieve reversible de-identification, the similarity between the original face and the correctly decrypted face is maximized, while all the de-identified faces are pushed away from the original one. To keep the best image quality and utility, image level and feature level reconstruction loss terms are imposed. We also use a parsing loss and a latent loss as regularization loss terms. Qualitative results are shown in this slide. For de-identification, RiDDLE generates smoother images with better photorealism. What's more, attributes such as pose and expressions are held at the same time. For identity recovery, our method achieves the best quality and some high-frequency details are added by our model during the recovery process, and our recovery process can be considered to be similar to super-resolution. Diverse identities can be generated with variations in race, gender, and other identity-independent face attributes. We also use RiDDLE to de-identify famous people such as Obama, LeBron, and Curry, shown in the lower right. For quantitative comparison, our method achieves the highest de-identification rate and the identity recovery rate. The Tieniu result validates that the diversity of our method is best compared with other methods. RiDDLE has also shown its superiority in image quality and utility. Ablation studies of some key components are shown in this slide. It can be seen that the transformer structure can greatly improve the image quality, thus bringing better de-identification and restoration. The model obtained from data-free training holds a competitive de-identification performance, but suffers from lower quality. Moreover, the ability to maintain the identity-independent attributes has been affected. Without the identity diversity loss term, the model can only generate images with the same identity. However, the identity recovery ability is nearly unaffected. To summarize, in this work, we first expose the drawbacks of the current face de-identification approaches and propose a de-identification method based on a novel latent encryptor and a password scheme. Our method, RiDDLE, achieves better quality, higher diversity, and stronger reversibility on various face datasets and in the wild images. This is a brief introduction to our work. Thank you for listening.